Okay, in 6.5, you were dividing monomials and polynomials. The big rule that you guys learned was that if I have x to the a divided by x to the b, so same base, you divide those, or sorry, you subtract those exponents, so that's x to the a minus b. So for example, we had in the warm-up we had, and I don't remember the numbers, but 20x to the fourth, y to the fifth, over 5, x to the second, and y, or something like that. So when we're dealing with a problem like that, this is a for example. We won't worry about it. Thank you, though. When you're dealing with something like that, as long as you are only multiplying on the top, you got no pluses or minuses to deal with there, and only multiplying on the bottom, then you can use this rule. If you start adding on the top and the bottom, that's where it gets tricky. You can't do that anymore. So what I'm going to do is split this up. I'm going to take my coefficients, 20 over 5. I'm going to take my x's, x to the fourth over x to the second, and I'm going to take my y's, y to the fifth over y. I'm going to look at this in two different ways. One of them is expanded out. If I have x to the fourth, that's 1, 2, 3, 4, over x to the second, 1, 2. Two of those divide out to give me 1, and I'm left with x times x on the top, so x squared. The other way to look at it is with the rule, x to the fourth over x to the second is x to the 4 minus 2, which is x to the second. So it really depends. Expanding it out is going to take you a lot longer, and at some point it gets really unreasonable to do. So it's easier if you can use this rule and just subtract your exponents. It's going to be a lot quicker and easier to deal with, particularly if your exponents get higher. So if I look at y to the fifth over y, that's technically y to the first. So 5 minus 1 is going to give me y to the fourth. And then what about 20 over 5? Those are the coefficients. I'm not dealing with them in exponent rules. I'm just going to either reduce the fraction if it can't be just divided. In this case, 20 divided by 5 is just 4. So when I wrap up my answer, this is going to be 4 x to the second, y to the fourth. When we're doing a problem like the first one, so I'm going to slide this back down, all we were doing on top was multiplying. We had no pluses or minuses happening, either on the top or the bottom. So we could start to divide everything out. When we're adding or subtracting on the top, like we are in this one, we can't just start canceling things out. What we have to do is separate this out into 3 different fractions. So 49x to the 7th over 7x to the 3rd minus 28x to the 5th over 7x to the 3rd plus 7x to the 3rd over 7x to the 3rd. Because as you may recall, when we add or subtract fractions, the denominator stays the same. So when we split it up like this to reduce, we keep that same denominator through each one. And then what we need to do is use our coefficients and our exponent rules to reduce that. So as we reduce this, we deal with each fraction separately. So the first one, what happens with that 49 over 7? What does that become? 49 divided by 7 is 7. And x to the 7th over x to the 3rd, what do we do with those exponents? Subtract. So 7 minus 3, so we have x to the 4th. Drop down our minus. What is 28 divided by 7? It's going to give us 4. And x to the 5th over x to the 3rd, what's that going to give me? x to the second. Don't forget to actually write the x to the second, because if you just put the 2 there, it doesn't work the same way. And then 7 over 7 gives me what? 1. What about x to the third over x to the third? That would also be 1. And that brings us to another real quick rule. If I have x to the third over x to the third, and I subtract my exponents, what is 3 minus 3? 0. So this would be x to the 0. Anything, because of this, and because x to the third over x to the third, anything divided by itself gives us 1, anything to the 0 power is 1. So that's another rule that we need. So anything to the 0 power, so x to the 0, is always going to be 1. So that pretty much wraps up 6.5. I mean, there's a bit more to it that you need to practice, so I would make sure you completed that worksheet. But can we do anything to reduce this part? No. How come? These are not like terms, so we cannot combine them.